are going to start talking about what's called direct variation. This video is a two-part video. I'm going to play the first part of this video in this section, and then you will have to go back to your document to click on the second video. So make sure you're watching part 1, and then you're following it with part 2. So I'm going to go ahead and I'm going to highlight my title, Direct Variation. And I'm going to highlight again down here, what is a direct variation? What is direct variation? Direct variation is a special line with a direct relationship. The direct relationship is as x gets larger, my y values get larger. Or as x decreases, y decreases. That's an example of what a direct relationship would be. Okay? So I now want you to highlight where it says what is the equation for direct variation. The equation for direct variation is y equals kx. And I want you to take a highlighter and I want you to put a cloud around that. Whenever you hear the word direct variation, you need to think y equals kx. That's the equation for direct variation. So this equation looks really similar to what? Hopefully you're all thinking y equals mx plus b. This looks really similar. I know this equation right here graphs a line because I have no exponents on my variables. So this obviously looks a lot like y equals mx plus b. I want you to pause this video and I want you to answer these two questions as best as you can. I want to know something that's similar about it and I want to know something that's different about it. Write down everything you can think, and then after about a minute, pause the video and I'll go over it. So some things that are similar, y is alone in both. There's a variable next to x, and m stands for slope, so m and k are next to x, which means they're equal. M equals k. So that just means k stands for slope. Okay? What's something that's different about it? They have no b. So if they have no b, what does that mean? B must equal 0, right? Because if it's not there, if I had y equals 2x, m is 2 over 1, and b is 0, so I'd be done. Alright, so here's the big moral of today. How can I remember what is a direct variation? There is no b. B equals 0. If your y-intercept equals 0, then it is a direct variation. So if I now come down here and I talk about what's called a constant of variation, a constant of variation is just the slope of a line. And with direct variation, we use the letter K. They didn't want you to see, I'm not really quite sure why they chose to pick K, but K just means M, which just means slope, rise over run. Okay? So if we go ahead and we look at some of these problems, it says, looking at the following graph, determine which one is a direct variation and explain how you know. If it's a direct variation, then find the constant of variation. So, alright, so let's go through it. Let's look at this. In order for something to be a direct variation, b has to equal 0. Okay? Explain how you know. Okay, I can do that. If it's a direct variation, find the constant of variation. That's just k, which equals m. Okay. So let's look at number 1. Looking at number 1, is it a direct variation? Yes. How do I know? B equals 0, because my y-intercept is right there, and it equals 0. So because y equals 0, it is a direct variation. I need to find k. K is I gotta find my slope. Pick two pretty points. Pick one, I pick the other. Rise over run. Draw straight. So let me erase it. Okay, well, so I'll just fix it. 1, 2, 3. 1, 2, 3. So 3 divided by 3 is 1. So k equals 1. Look at number 2. Number 2, is that a direct variation? No. How do I know? B does not equal 0. Because it's not a direct variation, I do not have to find k. If I look at number 3, is it a direct variation? Yes. How do I know? B equals 0. So now I have to find k. So pick 2 pretty points. Rise over run. 1, 2, 3, 4, negative 2. 4 divided by negative 2, k equals negative 2. Okay? So you're going to go ahead and you're going to try to finish the front side of this page. And when you finish, I want you to go on to the next video because the next video goes over these if you need help or clarification.